So here we are looking at the same example, but we're finding the missing side, but we're going to use our second method. So the second method says that usually Pythagoras' theorem is written as c squared equals a squared plus b squared. And that's looking at the hypotenuse. But if we want to find one of the shorter sides, we could rearrange that and have a squared is equal to the hypotenuse squared take one of the shorter sides. So we can, if we want, memorise this as an alternative formula. So let's look at our question. We've got a triangle. It's right-angled. We want to use Pythagoras. When I have a look at what information I have, the hypotenuse is C. My missing side, we said last time, it's easier to call it A. And then the one we know, which is also shorter, we'll call B. Now, I've noticed the one I don't know is a short side. So instead of using Pythagoras' usual theorem, I can use the rearranged version, and I can write that straight away. So I can write a squared equals c squared take b squared. Alright, let's start by substituting in. A, we don't know, so leave that as a squared. C, we do know, 14 squared. Take b is 8. So a squared is equal to 14 squared. Now we did this just a moment ago, but if you didn't check the other video, 196, take 8 times 8 is 64. Let's keep this a squared here. 196 take 64 is 132. Double check that on your calculator if you like. Now I want to get rid of this square, so the opposite operation to square is square root. Square root both sides. Remember that that will cancel with this, leaving me with a equals to the square root of 132, which is equal to 11.4, and I'm going to round it to 9. Metres is my units, 2 decimal places.